Hello and welcome to section 7.5. I know it says 7.6 on the slide, but these are older slides, so the numbers are a little off, but it is 7.5. Our objectives here are I can classify polynomials and write polynomials in standard form and evaluate polynomial expressions. So monomial, that's how you say that, is a number variable or a product of numbers and variables with whole number exponents. So, for instance, this is a monomial, this is a monomial. These ones are not, because you see here you actually have two combined into one. This one has one on top, one on bottom, and these ones, same thing. You would move this down, push the elevator button, and it would be just like this one. So you're looking for one single unit like this or this. The degree of the monomial is the sum of the exponents of the variables. Super easy to find. But a constant, which a constant is just a number like 2 or 3, has a degree of 0 because technically this is 2 and then x to the 0th. What is x to the 0th? That's 1. So 2 times 1 is just 2. So just imagine there's a secret variable there with a degree of 0. So any constant is going to have a degree of 0. Okay, that does not mean this, which would make it 1. It means there's an x to the 0th right there. I know it's kind of weird, but just remember a constant has a degree of 0. So looking at these ones, we're going to find the degree of each. So the degree of this constant is 0, so we're going to ignore him. And then you have p to the 4th, q to the 3rd, so the degree of this whole thing is 7. We just add those up. We're not combining these, we're not doing the multiplication anymore, we're just finding the degree of the monomial. Okay, looking at this next one, there's secret 1's here. So 1 plus 1 is 2. The degree of this one is 2. Okay, and here we have a constant, which is a number, so the degree is 0. Super easy. So let's look at this one. Okay, we ignore the number because it's just a degree of 0. We have k to the 2nd and then m to the 1st, so 2 plus 1 is 3. So you could write degree is 3. Okay, what about this one? The degree is 1 because this is x to the 1st. Okay, do you think you know this one? The degree is 3. The degree is 3 on that one. C to the 3rd. Super easy. So now a polynomial is a monomial or sum of difference of monomials. So before we just had like 2x. Now we're going to do plus 1. See, there's two things going on. So this is a polynomial because it has more than one. The degree of the polynomial is the degree with the term of the greatest degree. So this 1 has a degree of 0. And this part has a degree of 1. So the degree of this whole polynomial would be, well, which one's bigger? 1. Okay, I'll show you another one. So if I had x squared minus x, this part has a degree of 1, and this part has a degree of 2. And so, since this one's bigger, we're going to go with that one. This whole thing has a degree of 2. So the degree of the whole polynomial is determined by the biggest degree. So look at these ones. So this part has a degree of 7, and this part has a degree of 3. Which one's bigger? The 7. So the degree of this entire thing is 7. Okay, look at this one. Now this might be a little wonky. I have a z to the 1st here, so you got 2 plus 1 is 3. This has a degree of 3. This has a degree of 4. And this has a degree of 0. What is the biggest degree? Of 4. So this entire polynomial has a degree of 4. So you're just looking for the biggest exponent. Okay, let's look at this one. This has a degree of 1 because you have x to the 1st. 6 is just the degree of 0, so we just go with degree of 1. Ooh, this one has a lot to it. So find the degree of each part, figure out which is the biggest. So this has a degree of 5. We add those up. This also has a degree of 5. This has a degree of 4. This has a degree of 0. So what's the biggest degree? 5. And you don't have to choose which one, just, you don't have to combine them or anything. You just have a degree of 5. That's the biggest degree. The biggest degree is the degree of the entire polynomial. So in terms of polynomial, it may be written in any order. However, there's one way that is like proper grammar, if you want to think of it that way. Kind of like in English, you capitalize the first letter, you put a period at the end. We have a standard form of writing a polynomial in math. So that way it looks nice, and we usually write the biggest degree in the front. Now the number that's on the very, very front is called the leading coefficient. So, wow, this is just really moving today. So first of all, if I have 2x, that 2 is called a coefficient. Coefficient. Now if I had a polynomial like 2x squared minus x plus 3, since he's in the front now, he's now called the leading coefficient, or the LC as I like to call it. Okay, and we're going to be doing some stuff with them, identifying them. But this standard form is writing it in descending order. So looking at this, and let's just look at the original. What is the biggest degree on this entire thing? The biggest degree. Well, this has a degree of 1, this has a degree of 5, a 2, and a 0. The 5. So when we're writing this in standard form, we want to start with the biggest. So we're going to write negative 7 x to the 5th, because that's the part with the biggest degree. Okay, so we took care of him. Now what's the second biggest? The 4x squared. So we're going to write plus 4x squared. Okay, and we're just going down the line. What's next? Plus 6x, technically to the first, and then plus 9. This is called standard form. Standard form, and I know it says it right above, but I'm going to write it just to reiterate, and wow, I cannot spell standard. There we go. Okay, where we have the biggest degree on the left and the smallest degree on the right, and we just go in descending order, meaning it goes from biggest to smallest. Now they also want us to tell the leading coefficient. Remember, that's the number at the very, very front. So my LC here is, what's the number in the front? Negative 7. My LC is negative 7. Ta-da! Let's do it for another one. So looking at this one, identify your biggest degree, y to the 6th. So we wrote him, so I'm going to cross him out so I don't lose track. Now what goes next? Plus y to the 2nd. Now if you're not sure if it's a plus or a minus, just pay attention to what's in front of it. Because like this plus went towards him, this negative is going to go towards him. If there's nothing there, it's a plus. And then our very last thing is going to be minus 3y. Now what's our leading coefficient for this one? What's the number that's right there? There's a secret 1 right there. So our leading coefficient on this one is going to be 1. Okay, so just remember, if there's nothing there, there's a secret 1 there. Just a reminder. It's important to know. So let's write this in standard form, meaning we're going to write the biggest to the smallest. So our biggest is x to the 5th. And then our next biggest is 9x to the 3rd. And then we have minus 4x squared. And we have plus 16. And see, we're going in descending order. 5, 3, 2, 0. Perfect. I know we have some gaps there, but we have the biggest on the left, smallest on the right. What's my leading coefficient? Well, there's a 1 there in the front. Secret 1. So we wrote it in standard form, and we gave the leading coefficient. Okay, our next one, same thing. What's the biggest degree? Negative 3y to the 8th. Okay, our next biggest? plus 18y to the fifth, and then our smallest, plus 14y. And my leading coefficient is -3. Okay, now we're going to talk about some names that they can have. So we already talked about a constant. It's just any number. So if you had like 3, which is technically the degree is 0. And what I'm going to focus on first here is just the degree names, and then we'll get to the term names. So we already talked about constants, so you can have like 2, 3, whatever. We learned about linear equations back in the day where you had like x plus 1, y equals mx plus b. Notice there's an x. So if it has an x, or just any degree of 1, if you think about it, it's called a linear degree of 1. So you could have x, you could have y, but it has a degree of 1. A quadratic, like x squared, or let's say z squared, so he has a degree of 2, would be quadratic. Cubic, which you know cube before, has a degree of 3. And I'll bring in another letter here. Why not? And then 4 is quartic. And then you have quintic. Now, after that, 6 or more, you just say the 6th degree, the 7th degree, etc. But this is going to be the degree of the entire polynomial. We'll come up with this name. So, if you have x squared plus 1, this is going to be known as a quadratic because my biggest degree is going to be 2. If I have x to the 5th minus x squared plus 6, what's my degree of that one? It's 5. So my name would be quintic. This would be quintic. Okay, so just pay attention to what the biggest degree is, and that's the degree of the entire polynomial, and then you look at this chart to see what your name would be. Now let's talk about the number of terms. Number of terms is rather easy. First we talked about monomial, mono meaning 1. So if it has one term like x, that's a monomial. Binomial, bi meaning 2, binomial means there's 2 things, so x plus 1. See, 1 term, 2 terms. A trinomial, I think of it like a tricycle, tri meaning 3. I have 3 terms, so you might have x plus y plus 2. That would be a trinomial because you have 3 terms, and you know it's a term because it will be separated by a plus or a minus. And let's make this minus 2 just for kicks. Now if you have 4 or more, like a plus b minus c plus d, 1, 2, 3, 4, or more, this is a polynomial. Poly meaning many. Okay, and if you need to write those down, you can. This is also in OneNote, it's also in your book. And just remember this is section 7.5, even though the slideshow says otherwise. So we're going to classify this according to its degree and number of terms. So first, let's figure out what the degree is. The degree of this one. And what is the degree of this one? Well, the biggest degree would be that 3 right there. Now, how many terms are there? I talked about terms right there. They're separated by pluses and minuses. How many terms are in this particular case? We have 1, 2. 2 terms. So the way we're going to name this is we're going to start with our degrees. So a 3 was cubic, and then 2 terms is a binomial. And this is how we name this. We have a cubic binomial here. So when you are solving these, make sure you write out your degrees, your terms, and then come up with your name. Okay, let's find our degrees and our terms. So figure out how many your degree of the entire polynomial is of this one. It would be 6. Now how many terms are there? 1, 2, 3, 4. There are 4 terms. So let's start with our degree. A 6, ooh, that's a hard one, isn't it? Let's go back. 6 or more, we write 6th. Okay? So we can write 6th, and there's 4, so we can write polynomial. Oh, polynomial. A 6th polynomial. That sounds a little weird, doesn't it? There's a reason for that. This is not actually the way that you're supposed to write it. So the way you would write these is you would say a polynomial with a 6th degree. Okay, so it's kind of like there's weird instances in English where you just kind of have to rearrange the way you write it because it doesn't make sense. So anytime you have a big degree like that, you would say a monomial with a 5th degree, or sorry, not 5th degree, 7th degree, or polynomial with a 20th degree. Okay, so you just say what it is, the terms, and then you say with whatever degree it has. Okay, this next one, the degree is 1, and the number of terms is 1. So let's look at degree first. Degree of 1 would be linear, and then 1 term would be a monomial. So then this is a linear monomial. Okay, same thing here. So our degree is 3. Number of terms, 4. So this is a degree cubic terms polynomial. Okay, our next one's a little tricky. What's their degree? I notice it's a constant, so it's 0. And then how many terms are there? 1. So this is a constant monomial. Okay, our next one, our degree is 8. Number of terms, 3. So with this 8, since it's big, it's going to be with the 8th degree. I'm going to write this at the end. Now let's figure out a terms 3. So it's a trinomial with the 8th degree. Okay, so now we have a word problem, and this one's pretty easy. We just plug things in. So a tourist actually drops her lip balm off the Golden Gate Bridge. That's unfortunate. Hopefully it wasn't expensive. The bridge is 220 feet from the water of the bay. The height of the lip balm is given by the polynomial of this. We have a polynomial. It looks like it's a quadratic polynomial. Now, where t is time in seconds, okay, so how far above the water will the lip balm be after 3 seconds? So where do you think we're going to put this 3? Well, they told us time was t, so we're probably going to put the 3 in for t. So all we do is we plug this in, and just remember PEMDAS, you do 3 squared first, times it by -16, add, and so the 76 represents how far above the water the lip balm will be after 3 seconds. Now what do you think our labeling will be in this? Well, we were talking about feet up here, so it's probably feet. That lip balm dropped rather fast. That's how far above the water it'll be after 3 seconds. Okay, so these are the type of things we're going to be getting into with the quadratics and other kinds of things, all kinds of polynomials. So sit back, get comfortable.